Hey folks, here at Biomerics in an automation cell with Ken Hogue, VP of Engineering for Micrometals, and Mike Walsh, Director for Automation. Ken, can you give us a little overview of automation? We talked a lot about design for manufacturing and a little bit about design for automation. Can you talk to us at a high level about the automation and how you approach it and the capabilities?
Yeah, as we look at automation, we really think about the volumes that the customer is going to need in the program, the scaling of a program, and really automation brings a consistency, a quality level, the ability to inspect, and risk reduction for our customers. It has to do with capacity. As we scale shifts, we're not adding more and more and more people to the line. And that consistency, that ability to scale, and that capacity really reduces the risk for our customers.
Ken, do you ever take the approach where you go from a manual process to a semi-automated, then to a full scale?
As a product scales, it's often that low volume. And those first prototypes are often made in a manual process. And at the next stage, higher volumes, you're semi-automated. You've taken a few key aspects of the job, and often the fixturing is the key to any manufacturing process. And as we take that semi-automation and we take it to full automation, we've got the highest capacity available and the most consistency and quality.
Interesting. So the fixturing is the enabler in a way.
Absolutely.
Mike, Ken did a good job giving us a high-level overview of the automation capabilities here at Biomerics. Can you dig a little deeper for us and talk about a specific application?
Yeah, so behind us we have an application that Ken was talking about just before. This was a lower volume prototype product. The volume increased. We had a semi-automated vision-guided welder that we ran this on for many years. And then as the volumes went up, we decided to fully automate it. So what you see behind here is basically all the steps that were taking place in a more manual or semi-automated approach. And we took all those and kind of applied robotics and vision to those to get the cell you see behind you.
Mike, when you approach an automation project like this, I think what might set you apart, and you can correct me if I'm wrong, the automation, you're doing that in-house. You don't have a firm do the automation cell for you. You have the capabilities,
Absolutely.
Expertise, and resources to do in the house.
Yep. So the kind of approach we take, I call it the action out approach. So we have all our centers of excellence here. So let's take welding, for example. We have all the welding expertise right here in-house. So we sit down with our welders and we go over what the process looks like. And then we basically build a machine around it. Where do the parts come from? Where do they have to go? And then we kind of build the whole cell to kind of fit the process. So we're not worried about footprint first. We're taking care of the process first, and then we kind of build out and rings around that.
Mike, continuing to talk about automation, and I think this is interesting because of the vertically integrated capabilities, extrusion, molding, laser welding, you kind of tie it all together in this cell. But unlike the other example where maybe you started with design and then went maybe semi-automated all the way to automation, this is a different case. Tell us about it.
Yeah, so we had to develop the automation in tandem with the process development itself. So that presents all sorts of challenges from a process standpoint where you don't have years of experience running this component to kind of lean on. So we have to be agile and quick, and we come up with a problem, we have to be on top of that with solutions. So what you see here is kind of the culmination of all those iterations, right? We get the parts in, they don't quite fit up, we got to make a change. The tolerances don't quite meet the print, we got to make a small change. So, doing that is its own challenge, but we were able to accomplish that and bring in the vertical integration to kind of ramp up into a production schedule in a quick and efficient manner.
Ken, I often say that in order for a manufacturer to participate in some of the high growth, high value applications such as structural heart, surgical robotics, electrophysiology, ideally you really need to have the full complement of extrusion, molding, plastics, integrated with metals capabilities and bring it all together. Tell us how you vertically integrate these different competencies.
Yeah, that's a great topic. I think We really try to match the life cycle of our customers' products and have solutions that have integration of a machine component that gets micro overmolded to a MIM component at higher volumes that could be overmolded, and then at the highest volumes integrating a metal stamping into an overmolded product or application, and trying to fulfill the full life cycle of a customer's product in that way.
When you talked about the full life cycle, you're talking about starting from almost a sketch on a napkin to manufacturing and then maybe to full automation.
That's right. We really like to get involved early with our customers to provide design for manufacturability feedback. We talked earlier about the key aspect of a manufacturing process is often the fixture. And sometimes the design of the part really impacts your ability to fixture it correctly. Our customers' design engineers are thinking about the design and the functionality of the final product. And our engineers are thinking about the manufacturing, how we're going to hold this part, how we're going to measure it, what are the key datums and tolerances of the part as we go through the manufacturing process. And all along the way, we want to provide that responsive, quick turn, prototyping, and development capabilities to serve that early stage development of a new product.
Ken, when we talked about earlier about centers of excellence, as it relates to R&D, are there certain centers of excellence or certain sites within the micrometals division that cater more to the early stage R&D and then maybe transfer? Tell us a little bit about that model.
Yeah, we have all sites that participate, but we're evolving to focus on a theme called Rapid Fire Labs with a core site that will be the center point of a process of developing very quick turn capabilities focused on that very early stage development. And as needed, coordinating with all the other sites and all the other centers of excellence to bring the solution to the customer.